In this video, I'll be going over various techniques that allows us to create this design, which is a vertical facade that has a region that has been separated. And we then create the algorithm to extract some of that geometry, then play around with the scale factor by moving that facade to one side. We can increase and decrease the size of the region that we want to affect, move it around, and we'll share here two different options. So we'll have NURBS curve and we'll have an interpolated curve that then at the end we develop into this facade. I'll be going over all of the steps here. So thank you very much for being here. The purpose of these videos is to share with new Rhino and Grasshopper users how to get started by sharing with you various techniques and exercises that can help you get used to how parametric design works. So if you want to learn more and support my channel, check out my website where I have scripts, I have workshops, and a few other things that can help you get started and learn how this program works further. Let me know if you have any questions, and let's go ahead and jump right in. First thing we'll do is type in units here inside of Rhino and make sure that we're either feet or whatever units you want to have. This is going to determine the overall size of your facade. So we'll do feet, decimal is okay. And then here inside of Grasshopper, we'll go to a new document. Then under display, make sure you have icons, fancy wires, and names enabled. This way you see the script the same way that I have it displayed here. So now let's go to a XZ plane. And this is because by default, when you create a plane, it's going to use the default XY plane, which is what you see here, the red and the green lines. Now with this XZ coordinate system, we can actually create the plane on this reference. So now let's go here to plane surface, which is the component we want to use. So we'll plug in that plane into the plane input, which means it will use that reference plane as the input, right? So it's going to be creating it here. And now we can change the X and Y size. So I'll go here to 50 and then create a copy. So I like to slide down, tap Alt to create a copy. And now we can change the size of the facade. By what we want to do by default, I would say is be able to change what surface we're working with. This way, this way you don't have to create it parametrically, and you can actually insert, let's say, a different surface rather than this one that we're creating here. But the reason why we're doing it like this is to do it fully parametric here, and then have the ability to change it later. So now with this plane, we'll plug that into a surface input. This will allow us to change this input, so we can unplug this and we can set one surface to something else. Now we can take this and subdivide it using isotrim. As you can see here, we have both of these planes being displayed, so we can just select these, middle click, and disable preview. And now we're just looking at that surface. Next, we're going to be subdividing it using isotrim. So let's go here to ISO to find the isotrim component, which I always bring in with divide domain squared. These two together will subdivide that surface by plugging in the surface output into the input of isotrim and in the input of the domain. And by default, when you hover over U, it's going to say 10, and then V, it's going to say 10. So it's going to subdivide it 10 and 10 evenly in the U and in the V, which is going to be like the X and Y of a surface. So we'll take the segment, plug it into the domain. And what we want to do is, rather than having so many subdivisions vertically, we want to have only one and then only vary them horizontally this way. So we'll go here to 1. And it's going to be not the U, but 1 in the V. Next, we'll be adding another slider. So I'll go here to 15. Now we can subdivide this surface once vertically, which means it's just going to create these horizontal subdivisions. And now we can take all of this and hide it. Take the original surface, hide it. And now we're going to be working with this surface. With this subdivided surface, when you hover over the output, it's going to say 20. So we have 20 different surfaces here. And the way we know that also is because if we bake it, and then I select this, I can move it to the side and I can see that I've actually created 1, 2, 3, 4, and so on, 20 line segments that are subdivided vertically. So now if I go here to shaded mode, we see that this is what we want to do, but what happens is we want to work with the lines that are in between, and we don't want them to be redundant. So if I select this and then this one, you see that this one has a curve and this one has a curve. So if I extract all of the lines, there's going to be duplicate ones. The way to fix that is going to be to select this. Let's type in join here inside of Rhino. And when you join it together, now we only have the creases that is only one line here. And that's what we want to do inside of Grasshopper. So we can just select one line segment per subdivision. So what we'll do is we'll take this and type in join brep or brep join. The output says one open brep. So now let's disable the preview on this. Now let's take this and plug it into brep edges. And this is going to give us line segments for the naked and interior curves. The naked curves are going to be the ones on the outside, and the interior curves will be the ones here on the inside. So now we'll take those and plug them into a curve component. This way we can extract it because we have both of those inside of this component. So this way we can kind of take them out and we can select them independently of each other. Now let's disable the preview here. And now all we need to do is create a region within this surface that we can use to extract the pattern. And so we'll be taking that step here, which will be a point, a rectangle, and then where the information intersects, we'll be extracting that. Let's go back to the original surface, which is going to be all the way back here to this plane or this surface. So what we'll do is extract a point within this surface. And the way I like to do that is using evaluate surface. We can use this surface as the surface input. To get it to work correctly, we have to reparameterize, which means it'll turn this surface, which is whatever size it is. I think right now it's 50 by 81. So 50 by 81, and it'll turn it into 0 to 1 and 0 to 1. And this way we can pick from 0 to 1 a point within that surface using MD slider. And the MD slider, like you see here, goes from 0 to 1 and from 0 to 1 and puts it at 0.5. So this is what we'll use as the input point. And now since it's been reparameterized from 0 to 1, and this creates a point from 0 to 1, with this graph, we can move this point around and visually move this point, right? If we want to be more accurate, there is another way to create a point. The way to do that is to go here to construct point, and now we're going to pick an X and Y point within 0 to 1. So what we'll do is we'll go here and go here to 0.800 and then here to X 0.8 or X and Y at 0.8, and we'll use that point as a point input. And now we can go let's say 0.1 in the X and 0.5 and here in the Y, which would be in the U and the V. And now with this, we can be more precise as to where we want to create that point. But the reason why we use the MD slider is because it gives us a really cool, in my opinion, cool way to visualize where the point is located, and it does give you some fairly accurate like numbers here for you to kind of place a point. And then if you want to go further and say 0.37 and 0.45, then you can actually add those here and be more accurate. And here, then what we want to do is using not necessarily the point, but the frame, because as you can see here, we have this red and green arrow or line that's going to determine our X and Y. So now we can create a rectangle using this rectangle component, and we can use this point or this frame input and create an X and Y size for that rectangle. So we'll go here to 15, copy this over, and then 15. So now we've created a rectangle on this point, which was created on the original surface, right? And if we move that point, we're able to move that rectangle. The cool thing about this is then we can change this, and now we've created the region that we're going to be affecting with our design later on. And here, let's further enhance our design by changing this up. And with this, we can move on to the next steps. Just cleaning some of this up. And I'll actually go here, call this facade. This is going to be facade size X. And then sometimes I go here, Control A, Control C to copy, and then Control A, Control V to paste. And then we'll change the X to the Y. So we'll move on here, and these are going to be subdivisions. Then here, X and Y, this is going to be the region. Region X, and then here we're going to have region Y. All right, and then this is just going to be an option. So I'll go here to Control G and call this point, and then we'll leave this as okay. So with this, let's move forward and create the rest of the facade. These interior lines, and then we'll go here to this rectangle and go to boundary surfaces. This way we can basically create an overlapping surface on top of that surface, and then go here to intersect tab, and then physical between B-rep and curve. This way we can now plug in the interior curves into the curve input and the surface into the B-rep. Now let's select both of these and disable preview, or actually disable preview just on that surface. And when we select this, now we're able to see that we can select that area, and specifically those verticals. Okay, so with this, we also want to get the difference, right? So if we have these, we also don't want to have only all of the lines. We want the lines on the outside and not on the inside. So what we need to do is go to region difference and subtract from the outer plane, which is this one, subtract the rectangle, which will basically cut out this hole. Now we can do the same thing with boundary surfaces. Where we create a surface around that opening, and with that we can now do the same intersection. So we'll go here to the intersect tab and we'll do B-rep with curve. So we'll intercept this B-rep with these curves, and so now we have basically extracted the pattern from that overall pattern there. So we have this, the outside and the inside. So the next step is going to be to take these verticals, deconstruct them, and then reconstruct them using 3 different points. And actually we may use 1, 2, 3, 4, and then 5 points, so we can create more of a seamless curve here. So let's get started with that. But first, let's organize our things here. Make sure we're kind of looking at everything correctly. So bring back the original surface. And now we have these 2 patterns. So with these inside ones, which are the ones here at the bottom, we're going to go here to end points. And let's lower the count of the subdivision. So we'll go here to something like this. And I'll extend this and extend now that you see here, we have the start 7 points and end point 7 points. So 1, 2, 3, 4, 5, 6, 7. And we're going to take those out into their own point component. We're also going to take these lines and get the midpoint. So I'll go here to curve middle. And I'll do the bottom points here, top points here, kind of organize them here visually from top to bottom. And then here go to a new point or slide and tap Alt. And we'll plug those midpoints into the middle one. Now what we need to do is take these points and we need to extract one of the points and scale all of these relative to one of the endpoints. So I'll go here to Item or List Item. And when we use List Item, we'll be able to pick one of those. What happens is they're here grafted, so we do have to flatten the input. And then here at the output, we have one value or 1 point that we can now use to scale. So we'll go to Scale. And we'll use this point as our center and all of these points as our geometry. Now we have to be careful because now we need to flatten the input of the geometry. This way we only have as an output 7 different points. This way they connect seamlessly here. So what we need to do now is connect those points using NURBS curve. So now we've scaled this side down, and then here for the factor, we'll type in 1.5, or it actually has to be less than 1. So we'll go 0.888. This way we have 3 decimal points, and we can move this around here. Now let's take our original points. Let's disable the preview, and then these points back here, the midpoints, will also disable the preview. Now we'll go to this one, scale this up and down. Now we do have to graft it here out when we go out, but I'll do that here because we do need to scale these by 1. So now we'll take these and we'll go to Move. And we're going to move them up in the Z direction. So we'll go here to Z direction and we'll do 1.50. And then we'll do the same thing, but down. So we'll copy this, go slide it down, tap Alt, we'll make a copy. And this way we'll create a negative so we can create those same points, but going down. And so this is going to make it a lot smoother for us to go between this curve and then here. And actually, we don't need to move that set. We actually need to move this set up and then this top set down. This way, that will create a smooth curve. And you'll see here in a second how that's going to work. So now we've scaled this down by 0.5. Now we're going to scale again, but this time this and this by a factor of 1. So we'll unplug the factor, set number to 1. This will be the bottom one. So I'm organizing them visually. I know some of the wires are kind of overlapping here, but that will make sense in a second. Because now we need to do this to the top. So we'll copy this up and copy this down. The up ones are going to go with these. And the bottom ones will use this. The reason why we're scaling it by 1 is because all of the outputs will be using the same scale component, and this will fix a lot of the issues that we'll have. Some of the issues would be that they wouldn't create the curve. So we'll go here to NURBS curve. And one of the things we need to do is if we plug them in holding down shift, you'll see that it'll just create a zigzag. And we actually want to graft the output we'll go here to NURBS curve again. We'll start with the top. And the next one, holding down shift. The grafting right now is not working, so we'll go here to a graft component. Let's see if this will. Oh, so here's the issue. We have 15 points on this one, and that's because we have basically taken this, moved it, okay, so that fixed it. We'll remove the graft from these and then continue on adding in more inputs. And so the important thing is that as the output we have 7, this one we have 15, so this one's also giving us some issues. But this one is because we need to flatten the input. Then we have 7 values, and now we can add an additional input, and then here lastly we have 7. We'll make a copy and then merge these together using graft and NURBS curve, right? So what did we do? We took outside point, the end points, move them up, top points, move them down, and then the midpoints and scale them to one side. Now we can take all of these points, disable preview, and then scale down here and remove, since that they're basically overlapping, is take those away, and now that takes care of it. And the reason why we did this one is because this will help us make it smoother or not. And then the cool thing, in my opinion, is being able to move this region and have it update. And then here we can add more and it will also update. So the cool thing would be to add more vertical. And then here, here's the thing. This is using NURBS curve. We can also use interpolate curve. So all of these are going into one. We'll do the same thing here. And this one is a bit more drastic. And then I think the upper limit here, you may want more. So let's clarify that these points that we moved up and down, we had not flattened the input, therefore it was creating extra points. Now that we flattened that input and we made sure that we only have the outputs that we need, then in here they come in and we have it scaled down. The next portion, what we're going to do is take these lines and these curves, and we're going to extrude them to finalize the design and give this some dimensionality to the facade. You'll be able to apply this to any surface, so I think that's one of the cool things about this. And so let's move into that. Now let's take both of those inputs and we'll bring in a join curves. We'll plug that first. Then we'll go on to get the outside portion of the region. So holding down shift, I can add those in, and then I'll flatten the input. This way, when I see on the output, we have 35 curves that have been joined. We can basically disable preview on the originals. Then what we'll do is go here to endpoints. Here down on the ground, we're going to have top and bottom ones. So at the bottom, what we'll do is at the start, we'll go here to a circle. Or actually, we'll create a rectangle on this one. So we'll go rectangle at the start point of all of those, and we'll give it a size of 1.50. And we can have a different size for X and Y's here. So okay. And now we'll take that and we'll go to extrude along. And we'll extrude these curves along these curves. Now I'll make sure here at the end to bring in cap holes. And then we can now disable preview here. And basically it's taking this box down here and extruding it along continuously all the way up to the top. And let's change here the dimensions. The spacing. Oops, here I did simplify. And lastly, to give this like an outer frame to the facade, we'll go to the surface, go to surface edges or B-rep edges, and we'll plug in that surface into the B-rep edges, which will give us our naked curves, which are the ones out here, and then we'll be extruding it in, or offsetting it first. So we'll go here to, well, what happens is when we have that surface, we can automatically offset it. We don't necessarily need to bring the B-rep edges. We can just offset this and offset it to the, well, we will offset that to the outside. So I'll go here to boundary surfaces. Between these two, and then I'll flatten the input. Now I'll go to extrude in the Y direction, and I'll extrude it by the depth of this, so 53, or it's not going to be 53, it's back here. 4.54, so we can technically take this all the way to the front. Disable the preview, and that basically takes care of that facade with that portion of the script. Now, one of the things I want to do and make sure is here, let's organize this. We'll go to subdivisions. We kind of had this for the most part, but we went fairly quickly on this part. This is going to be height offset. So this is going to be scale size. I do Control A to select everything and then do scale. I accidentally disabled it, so we'll go here to or this is going to be verticals. X verticals, and then I'll copy that. And technically you can label them anything as long as it kind of reminds you of what exactly it is that it does. And now that gives us that portion. The cool thing is now we're going to go here under perspective view, then go to the front view and then type in plane. Or let's do this. We'll create a box. And let's say this was your building. You can explode it, select this surface, and we'll go here to set, deselect this or unplug it, holding down Control. And then we'll go to set one surface. And now it will do it to this surface. So that's one of the cool things, is that we can then apply it to our designs and not necessarily have to do the work all over again. And also this will give you an idea of how powerful this program can be and how many different designs you can program. Also with different tutorials, you'll learn different techniques, and the more techniques you know that you can combine, it will actually help you become a very powerful designer and come up with many different designs. So thank you very much for being here, and I hope to see you next time.